Hello friends, welcome to this video lecture of transportation engineering, and today we will be discussing about overtaking side distance. We all know the minimum side distance that is required at any point of time in front of a driver is the stopping side distance, and we have discussed in our previous classes about the calculations about the different aspects of stopping side distance. So now we see that overtaking is one of the very important phenomenon that takes place when a driver is driving a vehicle, because all the vehicles are not moving at design speed. Suppose a vehicle is moving at a design speed, there will be several other vehicles which are slow moving, which will be moving at a slower speed than the design speed. So now the vehicle which is moving at the design speed will tend to overtake those slow moving vehicles. Now the driver who wants to overtake should have on his clear vision an appropriate amount of side distance so that the driver may overtake the slow moving vehicle without causing any accident. So how much is that distance? We are going to see in detail about that distance, which is known as overtaking side distance. There are various factors which affects the overtaking side distance. We are going to see in details about those factors. So basically, what do we understand by overtaking side distance? The minimum distance open to the vision of the driver of the vehicle intending to overtake slow vehicles ahead with safety against the traffic of opposite direction is known as the minimum overtaking side distance, which is also known as safe passing side distance. So moving forward, these overtaking side distance depends on some predominant factors. Now, what are the factors on which the OSD, overtaking side distance, also known as OSD, what are the factors on which this OSD depends upon? The most important factor on which it will depend is the speed of the vehicle who is tending to overtake, that is the overtaking vehicle. Next, the speed of the overtaken vehicle, that is the slow vehicle. And third, also it will depend on the vehicle which is coming from the opposite direction. If suppose a vehicle tends to overtake one vehicle, then there will be some another vehicle which is coming from opposite direction. The speed of that vehicle will also have an impact on this OSD. The distance between the two vehicles, that is the overtaking and the overtaken vehicles, will also affect the OSD. Skill and reaction time of the driver. We'll observe as we discuss about the OSD that once a driver which is moving at a higher speed tends to overtake the slow moving vehicle, it will not overtake at that high speed at which it is coming. It will at first decrease its speed to that speed at which the slow vehicle is moving, and then after moving a considerable time in that slower speed, the vehicle will overtake by putting acceleration, and then the overtaking process will happen. So this overtaking procedure will also be affected by the reaction time of the driver. That is the time we have already discussed, that what is the reaction time, that is the time which is depending upon the PIEV theory. So the reaction time at which the driver will decide that whether the overtaking procedure will take place or it will not take place, that in that time also the vehicle will move certain distance of the, and that distance is also counted in the OSD. Okay, then the rate of acceleration of the overtaking vehicle. I have already said that the overtaking vehicle will first slow down to the speed of the slow moving vehicle, so then it will again accelerate. So when it will accelerate, what will be the rate of acceleration? It is generally 0.9 or 1 meter per second square. Next important factor is the gradient of the road. The overtaking side distance required for a steep gradient will be different compared to the overtaking side distance required for a plain gradient road. Next, in this sketch, we can very nicely view the phenomenon of the overtaking side distance. Observe that there are three vehicles: vehicle A, vehicle B, and vehicle C. I request all of you to take a pause and understand this figure first of all, because this is the figure which is the very important which will actually help us to get the overtaking side distance. So it is very important for you to understand this particular sketch. So you may take some time, take a pause, you may draw down this figure on your notebook, and then try to understand step by step. Okay, so how many vehicles are visible in this figure? Three vehicles, A, B, and C. And all these are different positions of A, B, and C, which happens when the overtaking procedure is actually taking place. Okay. So see, at this point, the vehicle A observes the vehicle B and it decides to overtake. And then it comes at a slower speed, and till it reaches this point, it is moving at a speed of the vehicle B. Initially, it was coming at a higher speed. Let us say, for example, 90 kilometers per hour. Then, while it reached here, suppose the speed of this vehicle is 40 kilometers per hour. Now, this vehicle A also reached a speed of 40 kilometers per hour, and then it realizes that it can safely overtake before the C reaches from this to this point. It can safely overtake and reach this point. So it starts the overtaking process by applying acceleration, and then it overtakes and reach this point A3. And while this A reaches A3, B is also in motion. So B also moves from B1 to B2. At A1, A starts decelerating, decreases the speed, then it reaches A2, it starts accelerating, it reaches A3. So in that particular time, C comes from C1 to C2, and B also changes its position from B1 to B2. I think all of you are able to understand this particular logic. So dear friends, please see, this overtaking side distance is from this particular point A1, to this particular point C1. And this entire overtaking side distance is broadly divided into three distances, D1, D2, and D3. We can see very clearly D1, D2, and D3. So we will see step by step how to calculate D1, D2, and D3. Okay. So the speeds of vehicle A is VA, vehicle B is VB, and vehicle C is VC. A and C are taken to be moving at design speed, and B is considered to be a slow moving vehicle. So since A and C are moving at design speeds, we are considering their speeds as V and speed of vehicle B as VB. Now we will calculate the distance D1 first of all. Gradually we will calculate D2 and D3. Now to calculate the distance D1, it is very easy. Can you say what will be the distance D1? It is the speed of vehicle A multiplied by the reaction time of the driver. Now what is the speed of vehicle A? The speed of vehicle A will be equal to VB, not VA or V. Please try to understand why. Because the vehicle A applies brakes and decelerates and reaches the speed of the slow moving vehicle at this particular point. Okay, so that is the reason this speed of vehicle A is considered to be equal to VB and not VA. VB, that is the speed of vehicle A, which becomes equal to speed of vehicle B. If any of you drive vehicle, you might be able to understand well, because when you do the overtaking process, it is that way you do. You apply brakes, you come down to the speed of the slow moving vehicle, and then you start accelerating. So distance D1 is the distance traveled by A in reaction time. At this stage, A is forced to move with same speed as of B. That is why the distance D1 is equal to VB multiplied by TR. What is TR? That is reaction time of the driver. If you have forgotten what is reaction time, I suggest all of you to again view the lecture on stopping side distance. It will be clear what is reaction time. And this equation is equation number 1. Let us move forward to understand the calculation of D2. The D2 is the important parameter. Okay, so we will see stepwise how the distance D2 is calculated. Okay, if you draw this diagram on your notebook, it will be easier to understand. So see, the vehicle A moves from position A2, the vehicle A starts accelerating, shifts to the adjoining lane, overtakes the vehicle B and shifts back to its original lane ahead of B in position A3 in how much time? That time is taken as capital T seconds. Okay, so dear friends, please try to understand in T seconds, capital T seconds, A moves from A2 to A3. How much distance A moves? D2 distance. How much distance B moves in the same time, capital T? B moves from B1 to B2. That is the distance capital B. Please observe here, the distance D2 is divided into three parts, S and B and again S. So this distance B traveled by the vehicle B is same as the distance D2 takes the same time as the vehicle A has taken to move this distance D2. In the same amount of time, A has moved D2 and B has moved distance capital B. So the straight distance between A2 and A3 is taken as D2. The minimum distance between points A2 and B1 may be taken as the minimum spacing S. Okay, so let us see what is S actually. This S, that is the distance between A2 and B1, and the same distance S is between B2 and A3. That is the minimum distance between the two vehicles at that particular slow moving speed. Okay, so what is that particular distance S? Okay, this is given by an empirical formula, and the formula to obtain S is 0.7 VB plus 6. Capital VB, when it is we are writing capital V, that means in kilometer per hour. S will be in meters. You will be now confused. You will be thinking how S will be in meters if V is in kilometer per hour. That is why I have given you one separate equation. See here, in this equation, S is written as VB into TR plus L. We are writing it as small VB. Okay, small VB means in meter per second. So when the vehicle is speed is in kilometer per hour, suppose 40 kilometer per hour, to convert it into meter per seconds, you will multiply it by 0.278. Okay, when you multiply 0.278 and consider a reaction time of 2.5, you will get 0.278 into, suppose 40 is the in kilometer per hour. So when you multiply 0.278 into 40, that is the speeds in meter per second actually. So automatically, though we are considering the speed at 40 kilometer per hour, since you are multiplying it by 0.278, it automatically gets converted into meter per second. Okay, so when you are writing 0.278 into 40, that is kilometer per hour, suppose for example, multiplied by 2.5. Now you multiply 0.278 into 2.5, you will get approximately 0.7. You will get approximately 0.699, considered to be 0.7. So this 0.7 is coming by multiplying 0.278 into 2.5. And since we have considered that 0.278, that is the conversion factor from kilometer per hour to meter per second, that is why the S is coming now in meters. Okay, do not get confused. Later on also there will be many such places where in the formulas we are using in right hand side kilometer per hour, but the answer is coming in meter per second. But it is not directly coming like that. Some conversion factor is actually used while deriving that formula. That is why in left hand side if it is meter per second, in right hand side there is kilometer per hour. So you have to understand this particular concept. Okay. Now, the S is given by 0.7 VB plus 6. What is 6? 6 is the distance, it's an empirical parameter, 6 meters taken as the distance between the two, minimum distance between two vehicles. And 0.7 V is the distance that is depending on the speed of the vehicle. If the speed is very, very less, 0 kilometer per hour, then the spacing between the two vehicles will be approximately 0.6 meters. So when you are as much the speed of the vehicles are more, the more the driver will be in the tendency to keep them apart from each other. As the speed decreases, the vehicles moves more closer to each other. If it is 0, it will be minimum 6 meters distance exists between two vehicles. Okay. Now it is said that let the time taken by the vehicle A for overtaking operation from A2 to A3 is T seconds, capital T. I have already said that. Now, in that capital T seconds, the vehicle B moves from B1 to B2 and vehicle A moves from A2 to A3. Please refer the diagram. I have already said it. Now, please observe that in that particular time capital T, the D2 can be given as B plus twice S, capital B plus twice S. Okay, you already know the value of S. Okay, so capital B is equal to speed of vehicle B, that is VB, multiplied by T, capital T, because the vehicle B moves capital T times in the what to say, from B1 to B2, the vehicle B takes capital T seconds, so VB into T is the time taken by vehicle B plus twice S. This, by using this formula, you will be able to get the value of D2. Now this D2 can also be expressed in the equation form by the equation of motion, that S equal to ut plus half at square, because the vehicle A accelerates. Please observe, the vehicle A is accelerating from point A2. So since the vehicle A is accelerating from point A2, so this distance D2 can also be expressed as the distance covered by A2, that is the distance D2, S equal to ut plus half at square. U means velocity of A2 at this particular point, that is VB, isn't it? So S means the distance travel, that is D2, equal to VB into T plus half into A into T square. I hope all of you are able to understand this clearly. So now we have two equations, equation number 2 and equation number 3. Both the equations gives us what parameter? The parameter D2. But although we have two equations, we cannot find the value of D2 unless we get the value of capital T. We don't know how much time the vehicle B takes to move from B1 to B2. We don't know how much time vehicle A takes to move from A2 to A3. We can calculate the value of S, no problem, 0.7 VB plus 6, but we don't know value of T, so we are unable to get the value of D2. So let us equate these equations 2 and 3. Since the left hand sides of both the equations are same, D2, so we can write that VBT into T plus twice S is equal to VB into T plus half AT square. Let us equate and let us observe. So when we equate these two equations, we get T is equal to 4S by A. It's simple mathematics. All of you will be able to find that T equal to 4S by A. So since now we obtained the value of T equal to 4S by A, where S is equal to 0.7 VB plus 6. So when you have the value of T, you can now get the value of D2. D2 equal to VB into T plus twice S. That is equation number 2. Since it's a simple equation, we are using this equation. You can use any of these two equations. You will get the same value of VD2. Okay. So our first task to get the value of D2, our first task will be to get the value of S, 0.7 into VB plus 6. Our second task will be to calculate the value of T equal to under root of 4S by A. The value of A will be known to us. It's approximately 0.9 or 1 meter per second square. Then we can get the value of D2. So we got the value of D1 and D2. So now what? We need the value of D3 to get the value of total overtaking side distance. So D3 is very simple. It is the distance that is the traveled by the opposite vehicle, that is the vehicle coming from the opposite direction. It is the distance that this vehicle travels in capital T time. Now that vehicle is understood to be coming at a speed of the design speed, that is V. Okay, that is the initial speed of vehicle A, and the speed of the opposite vehicle is taken as similar, so that will be V into capital T. So now since we have D1, D2 and D3, what will be the value of OSD? Will be equal to D1 plus D2 plus D3. D1 is nothing but VB plus VB into TR. D2 is VB into capital T, plus twice S, and D3 is V into capital T. If we add up everything, then we will get the value of OSD. So before putting the values in this equation, we need to get the values of capital T and twice S. You know, so S equal to 0.7 VB plus 6, you can get the value of twice S. T equal to 4S by A, you can substitute this value of T and you can get the value of OSD. Okay, this VB and this VB both are same. This will be, you can write capital B only. Okay. So now there are two different cases of OSD. One is if there is no vehicle coming from the opposite direction, if it's a one lane, one way traffic. Okay, if there is only if the vehicles are moving only in one direction, there is no movement from the other direction. There are certain roads where there is only movement, unidirectional movement. There is no movement allowed from the opposite direction. So will there be any D3 at that point? There will be no D3. Why? Because there is no vehicle coming from the opposite side. If there is no moving vehicle coming from the opposite side, the OSD requirement will be less, that is D1 plus D2. If it's a multi-lane or two-lane road where there is opposite vehicles are coming, that will be, the OSD will be D1 plus D2 plus D3. Okay. Even in those roads where we have divided carriageways, there won't be any effect of the opposite vehicles. So OSD will be equal to D1 plus D2. Now let us discuss one of the important parameters known as overtaking zones. So what is an overtaking zone? It is a zone which is provided to overtake vehicles. Now suppose there is a highway where there is no sufficient, overtaking is restricted. There are certain roads where you are not allowed to overtake because the width of the road is not sufficient to allow vehicles to overtake, and because overtaking of vehicles may lead to crashes between vehicles or accidents. That is why overtaking is prohibited. You may find in places that overtaking prohibited signboards are mentioned. So where such places are there, after a particular interval, there should be a particular zone where overtaking will be allowed. So in that particular zone, the area will be provided, extra area width will be provided so that the vehicles can overtake. So these particular zones are known as overtaking zones. So to design the overtaking zones, what will be the minimum distance that is requirement for an overtaking zone? You must know the OSD, overtaking side distance for a vehicle. If you know the overtaking side distance, then only you can calculate the overtaking zone distances. Okay. So in the slides, you can see a typical sketch of the overtaking zone. So here, suppose when you see the left hand side, this is the signpost 1, which indicates that overtaking zone ahead. That means when you come here by your vehicle, you will understand that, okay, there is an overtaking zone. So if there is any slow moving vehicle here, you will start overtaking. And here in a signpost 2, it says that overtaking zone ends. So you should not start overtaking from here. Similarly, in the opposite direction, the signpost 1 is here, which shows overtaking zone ahead, and here the signpost 2, which shows end of overtaking zone. So this overtaking zone distance is approximately thrice OSD, minimum 3 OSD. This is 1 OSD. This distance will be 1 OSD to 3 OSD, and this is 1 OSD. So total will be minimum 3 OSD to minimum 5 OSD to maximum 5 OSD. Okay, and these distances are also 1 OSD. So you have to calculate the OSD first of all. How much is 1 OSD? Then you can particularly design the overtaking zone. So you may be asked in some questions that you calculate the overtaking side distance and you design a overtaking zone. So if you calculate the overtaking side distance, it is very simple to design the overtaking zone. Okay, so there is one problem where you have to calculate the overtaking side distance, and also you have to mention about the overtaking zone. So I hope that all of you have understood the concepts of overtaking side distance and overtaking zones. So basically the main point where you have to understand is the distance D2, and I think it is very easy to understand. First you have to calculate the value of S, and then we just equated the values of D2 by two different means, and then we have got the value of capital T by this means, and after obtaining the capital value of capital D, the D2 comes out very easily. So do revise it and check it that whether you are able to understand. If there is any doubt, you can contact me. So with this I will end the presentation. So understand the meaning of safe overtaking side distance and stopping side distance very, very clearly. These questions on overtaking sight distance are very common in various competitive exams as well. Okay. So with this, thank you so much.